So after we introduce how the stack template, we're using the playing card as an object, as a data. Now, how should we implement that? So this way I show you, see A, B, C, D. I look like this one is array, right? Right. So that's why the first thing we want to implement our stack template. Like earlier I said, we have two different approach. So the first one, we were using the array implementation on today's lecture. Then Wednesday, we will continue to talk about the linked list implementation. So then here is the suggest public interface for the array implementation for the stack template. So right, when we have our template, we have the template keyword and the type name. You see this V can be replaced with any data type. Our class name is stack. So you see here, right, our public interface. We definitely should have our constructor function. We definitely need to have our push setter function and the pop setter function. Then we need to have the clear will make our stack empty. So then remember we have the pick. So the pick actually is the getter function because we don't allow them to change the top the next value we will pop. So then we have three getter function, one pick, one size, and one empty. So now what should we have in our private data? So that's for the public interface earlier we see, right? So right, just like earlier I say, our stack implementation, the first one we will do array. So now array, remember our array, we have two different type array. Do you want to be static array or dynamic array? Do you think the array when we create, they should be fixed size, the fixed capacity, or the capacity can be resized, so then our stack can be push as many objects as we want. Right, of course, we need to have a dynamic memory, right? Right, so that's why since we want to have dynamic array, right, okay, I say here the dynamic array mean in the C array, I want to have a dynamic array. So this dynamic array, I'm not talking about the template we implement. I talk about is the array is in the dynamic memory. So this array in dynamic memory will be similar, right? Very similar like what we implement last week, the past week about the dynamic array. But here we don't use another library because remember, if you import another library, actually your performance will bring down because object actually take more space. But here, that's why since we can have our C array with the in the dynamic memory, right? Right, so just like we have before, we just have a pointer. So this pointer data type is, right, V. Okay, so then later, right, in our constructor, we will new the array and refill by the pointer. Right, so then that's later you need to initialize in the constructor function. So since we have the array, right, definitely that's dynamic. We want to have a capacity. So this capacity also is a private data attribute. So this cap in lowercase is for this dynamic memory array. How should we do? So we have cap, right? Then we also need to have another new attribute is size. The cap represents the array in dynamic memory, the capacity. The size represents how many objects, how many data I push into our stack. So that's why here is our public interface. So actually we have three private data. The first one is pointer. The second one is the capacity for the array. So then the size for the object. So you see, do you have question from that? So you can post the video, then think about your question and write it down. Okay, then you will say, what's this one? So remember this one is capacity, what? Capacity, private capacity, right? Setter function. Right, see this one capacity function is for what? Like we say, if user push the object into the stack, if the capacity not enough, I need to enlarge that. Then you will say, how come I don't have capacity getter function in my public interface? Right, we don't have that because for stack, user didn't know how we implement the stack. User only know, oh, I have a stack I create. I just push the data. What I need is I only need to know the size, how many elements in my stack. So how many data in my stack? Actually, how you will control your capacity, I don't really care. So that's why here you will see in our public interface, okay, for stack point of view, I only care my size. So far, how many object, how many data I push into my stack. Is my stack empty? Then I want to clear my stack. So the capacity actually that's leave for ourselves in the stack object. So that's why the capacity setter function is private. Okay, so you see, do you have question? And does that sounds good? So then we can do one by one. Right, yeah, since we are dynamic memory, so that's why we need to have constructor and we need to have destructor function. And we need to have copy constructor and assignment operator. So this one is our array implement stack template public interface. So then we will talk about the member function one by one. So the first thing, let's talk about constructor function. So do you think, how should we implement constructor function? So right, actually our constructor function is what? Yeah, constructor function, the purpose is what? Initialize all the private data. So that's why you see we have pointer, we have the capacity, we have the size. Okay, so that's why that's initialize all the value. Okay, so then we see how should we implement the constructor function. Like earlier we said, here is our public interface. So the first thing, how should we implement the constructor function? So remember when you have your constructor function, right, you still have your template function header, then your class header. So we have RV. So what should we do? Right, remember all your constructor function is what? Constructor function is to initialize all the value, right? Good, so the first thing, we have these three private data. Okay, so we do one by one, we start from the easy one. Can you tell me size equal to? Right, size equal to 0. Because it should be no object yet, right? Good. So this one will be different. Before, when we're doing the dynamic array, we have the capacity passing by into the stack. Okay, but like earlier we said, actually user honestly doesn't know the capacity for the stack because they have no control for the capacity. So that's why here we do need to have capacity is the data member function to remember what is the array size. But here the capacity actually is for the internal use. So that's why here the default value actually is up to you. So here, just like before, our dynamic array, we say the default value, we're using capacity equal to 2. So here actually just up to you. If you feel like, okay, I want my stack actually start from the capacity is 10, then you can change. Okay, so continue. Constructor function, the most important thing is to initialize all the private data. So now we have size, we have capacity. So now good, right? We have our, so our array equal to what? Right, that's dynamic memory, right? So that will be V what? So that's why our array created. Okay, so what else we need in the default constructor? Yeah, so the default constructor actually before we remember in the dynamic memory, dynamic array, we actually initialize all the data, right? So that's why you may think about, we may need a for loop. we may need the for loop to initialize all the elements in the array. Okay. However, actually this one for the stack, either way, if we want to have that to initialize, if we want to initialize default value for each element, you can do that. But honestly, this one is not necessary. So you can initialize every element in the array, but actually not necessary for the stack. The reason is stack, you cannot really access any element. You only can access the element being pushed in. So that's why here, if we want to initialize each element in the array, you can do that, but not necessary for stack. Okay, what else in the default constructor? Yeah, then you will ask, why we don't need the dummy? Yeah, later I will show you why we don't need the dummy. Yeah, because like earlier we said, for the stack or a queue, user not allowed to access any element. They only can allow to access the element they already been pushed in the value. So that's why we always have some value to refill the data. So that's why don't worry about that. You don't need a dummy for the stack. Okay, so that's our constructor function. So after we finish our constructor function, actually we can do a couple more. Yeah, because one thing is, since we have constructor function, our destructor function, we just need to delete the dynamic memory. Then since we have our constructor function finished, so then we will see here what else we can have. So that's finished the easy part for our header file. So then you will see, we see any inline function we can finish. Okay, copy constructor assignment operator, very complicated. I will talk about later. Okay, so push. Push we will do a little later too. So then here we will do the clear first. Okay, so clear actually is clear what? Okay, need to be careful. Clear just means, okay, I want to get rid of anything from my stack. So actually clear, we only need to assign the size equal to 0. So then the other inline function is the size. We just return the size. So then the bool function empty, getter function, we just need to return to check if size equal to 0. Yeah, it's empty, right? Otherwise we return false. So that's the inline function we can finish for now. So then, right, so later we will only need to do the push and pop and the pick and the constructor function the assignment operator I will talk about. So right, after we finish constructor function, let's do the next one, do the push, pop, and the pick. So the first one, let's do the push. So you will see the push, actually you need to give me the object you want to push, right? So since that's the object, we pass in by the constant reference. So then you see the push function also is a template function. So we have the template keyword, we have the return type, we have the class name associated with our push. So now we just say this object we want to push in data type is V. Okay, so we pass in by reference. We call the parameter is value. Okay, so how should we do that? So push. So we back to see here. You see, when we push A, B, C, D, we do like this, right? But actually, how do I know A I will put here? Right, did you remember in our duplicate check, we give you the array index. So that index actually not only for the boundary, right? That index actually is the location if I have a new element where I need to put. So that's why here the index for the assignment 5, that's for the class for array index. But that class index also for here for our stack is the size. Right? So you see, if I have the first element I want to push, actually I have the size 0 I will put there. So that's why how you will implement the push.